Understanding the difference between cutting speed and spindle speed is essential for stable machining, good surface finish, and long tool life. Many machining problems come from confusing these two concepts or treating them as the same parameter, even though they describe very different aspects of the cutting process. Cutting speed describes how fast the cutting edge of the tool moves across the surface of the material, while spindle speed, measured in revolutions per minute, describes how fast the tool or workpiece rotates. Both values are related, but they are not interchangeable, and each one plays a specific role in CNC machining. In CNC milling and turning, choosing the correct cutting speed and spindle speed helps control heat generation, reduces tool wear, improves chip formation, and increases overall machining efficiency. When these values are wrong, problems such as chatter, poor surface finish, built-up edge, and premature tool failure become common. Cutting speed refers to the linear speed at which the cutting edge moves along the surface of the workpiece, and it is usually expressed in meters per minute or surface feet per minute. Unlike spindle speed, cutting speed focuses on the actual contact speed between the tool and the material rather than how fast the tool rotates. Selecting the correct cutting speed is critical because it directly affects heat generation, tool wear, chip formation, and machining stability. Cutting speeds that are too high generate excessive heat, which shortens tool life and may damage the cutting edge. Cutting speeds that are too low can cause rubbing instead of cutting, poor chip evacuation, and the formation of a built-up edge on the tool. Cutting speed also depends strongly on the material being machined. Softer materials such as aluminum allow much higher cutting speeds, while harder or heat-sensitive materials such as stainless steel require lower cutting speeds to avoid excessive heat and tool damage. Tool material also matters, as modern carbide tools can handle higher cutting speeds compared to high-speed steel tools. In CNC machining, cutting speed is often the starting point for selecting machining parameters. Once the recommended cutting speed for a given material and tool is known, spindle speed can then be calculated to match that cutting speed. Spindle speed refers to how fast the spindle rotates and is measured in revolutions per minute. It tells you how many times the tool or workpiece completes a full rotation in 1 minute, but it does not directly indicate how fast the cutting edge moves across the material. Spindle speed is directly influenced by tool diameter. A small diameter tool must rotate much faster to achieve the same cutting speed as a larger tool. This is why using the same spindle speed for different tool sizes often leads to machining problems, even when the material and operation remain the same. Choosing the correct spindle speed is important for preventing vibration, chatter, poor surface finish, and tool breakage. Excessive spindle speed increases heat and centrifugal forces, while insufficient spindle speed can cause the tool to rub instead of cut effectively. In CNC milling and turning, spindle speed works together with cutting speed and feed rate to create stable cutting conditions. Changing one of these parameters affects the others, which is why they must always be considered together rather than adjusted independently. Understanding how cutting speed and spindle speed work together allows machinists to adapt quickly when changing tool diameters, materials, or machining strategies. This understanding leads to better surface quality, more predictable tool life, and fewer unexpected machining issues. If this explanation helped you, like the video and subscribe for more practical CNC troubleshooting.